Good morning, 6th grade. Mr. Hale here. I hope you and yours are doing well. I hope you're washing your hands, not touching your face, and staying at home as much as possible. I know I am. Over the last couple of lessons, we've talked about the relationship between percentages and fractions, and that you can turn one into the other using a setup where two fractions are set equal to each other. And then you multiply the diagonal and then divide by the number you haven't used yet. This setup, two fractions set equal to each other, has a very specific name. This is called a proportion. And a proportion can be used in situations other than converting between fractions and percentages. Proportions are extremely useful in a lot of real-world situations. What's great about this, based on our previous couple of lessons, is that the method we use to solve a proportion is the same as we've already talked about. Multiplying the diagonal and then dividing by the number that you haven't used yet. So, in our example here, we have 6 over 8 equals 9 over 12. If you remember our fraction unit, you'll remember that both of these things can be simplified down to 3/4. 6 divided by 2, 8 divided by 2 gives you 3/4. 9 divided by 3, 12 divided by 3 gives you 3/4. So those are indeed equal to each other. But in case we have a pair of fractions that aren't as simple to deal with, we can use what are called, hold on, let me find my pen here, what are called cross products. And that's just a fancy name for diagonal division. Because in addition to both of these being simplifiable down to 3/4, there's another mathematical trick that shows up. If you multiply your diagonals, 6 times 12 and 8 times 9, what do you get? Well, 6 times 12 is 72, and 8 times 9 is also 72. So the numbers that are diagonal from each other, when multiplied, have to give you the same result. That's why multiplying by the diagonal and then dividing by the number you haven't used yet works. So if we are presented with any proportion, any setup where there's a fraction set equal to another fraction, and of the 4 slots, A, B, C, and D, one of those slots is empty, we can use the system we've already learned, multiply the diagonal and then divide by the number we haven't used yet to find that missing number. So let's do this example as if we didn't already have the answer for us. Let's say that we had 6 over 8 equals 9 over question mark. Now we know the answer is 12 because that's given to us in the example, but we're going to pretend we don't know that. All right, so what do we do here? We've got 1, 2, 3 numbers out of a possible 4. How do we find the 4th number? First step, multiply our diagonal. The numbers that are diagonal from each other are 8 and 9, which gives us 72. And then we divide by the number we haven't used yet, which is 6. So we're going to divide that by 6, and that gives us 12. So this question mark can be replaced by 12. We know that's the right answer because of over here. Multiply your diagonal, divide by the number you haven't used yet. Let's look at some more examples down here. Okay, we've got 18 over 42 is equal to 10 over something. So let's look at the numbers that are diagonal. The numbers that are diagonal from each other are 42 and 10. And we've already done the work here. 42 times 10 is 420. Once we've done that multiplication, we're going to divide that answer by the number we haven't used yet, which is 18. Already done the work here for us. 420 divided by 18 is going to be 23.3. Do you remember what this line on top of the 3 means? It means that is repeating. So technically, this is 23.3333333333 and on forever. 23.3 repeating. So this x gets replaced by 23.3. How about this example? Now we don't know the thing in position A on the top left. We don't know what that is. Well, what is our diagonal? We have 125 and 20 that are diagonal from each other. 125 multiplied by 20 is 2,500. And then we take that number, that product, the result of the multiplication, and we divide it by the number we haven't used yet. 2,500 divided by 300 gives us 8.3. So this x should be replaced by 8.3. And once again, there's a line on top of that 3. So technically, this is 8.33333333333 and on forever. This works with fractions too. Check this out. We've got 4.2 over something equals 7.6 over 10.05. Well, here's our diagonal. 4.2 times 10.5. Already done the work for you. It's 44.1. Then we divide that result by the number we haven't used yet, 7.6. That gives us 5.8. So this number goes away and is replaced by 5.8. One more example. We have 25/38 is equal to 15 over something. Well, our diagonal is 38 and 15, so we're going to multiply 38 times 15. That gives us 570. And then we're going to divide by the number we haven't used yet, which is 25. 570 divided by 25 gives us 22.8. So this x goes away and is replaced by 22.8. This setup always works. If you have two fractions set equal to each other and one of them is missing, if you have what's called a proportional setup, two fractions equal to each other, the diagonals always have to multiply to the same result. Because of that, this system, multiply your diagonal, then divide by the number you haven't used yet, will always allow you to find the missing value. That's going to be very useful on all of these problems. See, these are all just those kind of problems. You just have to find the missing number. I'm going to do one of these word problems along with you, just so we know how to convert this idea into word problems. Okay. A flavor of frozen yogurt has 64 calories spread over 2 ounces. I'm going to put 64C and 2OZ, because those are for labels. And then we have how many calories are in 5 ounces. So I'm going to put C up here. We don't know how many calories there are in 5 ounces. When you are working with word problems, what you have to keep in mind is that the units matter. The thing you're measuring matters. The top number on this side is 64 calories. That means the top number on this side, the numerator, also has to be calories. The denominator on the left is ounces. That means the denominator on the right also has to be ounces. You can't mix and match where there's calories on top over here and then calories on the bottom over here. Calories and calories on top, ounces and ounces on the bottom. You could flip this over. You could put ounces on the top and then ounces on the top and calories on the bottom and calories on the bottom. You'd still get the same answer. What matters is that you have the same type of measurement, calories and calories, ounces and ounces, both on top, both on bottom. So let's figure this one out. 64, our let me get a different color here. 64 multiplied by 5, because that's our diagonal, is 320. Divide by the number we haven't used yet, which is 2. And I know this off the top of my head. 320 divided by 2 is 160. So there are 160 calories in 5 ounces of yogurt. So there's number 13 done for you. Let's make up another one off the top of our head. We'll just do it in this big white space here. Let's say that your car can travel 240 miles, put up MI for miles, on 8 gallons of gas. Okay? We want to know how many gallons of gas it would take for your car to go, let's say, 800 miles. Now, I want to point out what I said down below. Miles and miles are both on the top. I can't have miles on the top here and miles on the bottom over here. If I put miles on the top on the left, miles have to be the numerator on the right. That means that if gallons are the denominator on the left, then my unknown number, the number of gallons of gas I need to go 800 miles, has to be the denominator on the right. The type of measurement, your units, have to both be on the top, both be on the bottom. You can't flip them around. All right, so let's go ahead and work through this problem. What is our diagonal? We have 8 multiplied by 800. 8 multiplied by 800. Well, what's 8 times 8? That's 64. And then we just put the 2 zeros behind it. So 8 times 800 is 6,400. Then, once we have that product, that multiplication answer, we're going to divide by the number we haven't used yet, which is 240. Okay, another shortcut we're going to do here. We talked about this the other day. If both of these end in a 0, here's 1 0, another 0, we can get rid of those zeros. Make this a little easier to deal with. We now have 24 into 640. How many times can 24 go into 64? 24, 48, 24 times 3 is 72. That's bigger than 64. So we can go in there twice. 2 times 24 is 48. 64 minus 48 is 16. Bring down our 0. 24 into 160. So our multiple to 24 are 24, 48, 72, 96, 120. That's 24 times 5. 24 times 6 would be 144. So, yeah, so this can go in there 6 times. 6 times 24, we just said, is 144. That is a difference of 16. Okay, we don't have a 0 here anymore, so we've run out of numbers in the house of division. When that happens, we have to put a decimal point in our answer and start bringing down ghost zeros. We have another 160, same as we had here. We know that 24 can go to 160 6 times. That's going to give us 144 again, which is going to give us 16, which means we're going to bring down a ghost 0 and just go through this over and over again. We're going to keep getting 6s. That's why we use this bar. So our answer, how many gallons of gas will it take for this car to go 800 miles is 26.66666666666 gallons. So our answer here is 26.6 gallons. Now, I don't know what that sound was. I don't know if you even heard it. Okay, takeaway from this lesson. If you have a proportion, multiply your diagonal, then divide by the number you haven't used yet. If it's a word problem and there are units like calories and ounces, or miles and gallons, or dollars and hours, you have to have your units top and top, or bottom and bottom. You can't mix and match. Miles on top, gallons on bottom, calories on top, ounces on bottom, ounces on bottom. There's another strange noise. Multiply your diagonal, divide by the third number. That'll get you through every single one of these 15 problems. As always, do your best. If you have any questions, feel free to email me. Wash your hands. Don't touch your face. Stay home as much as possible. I miss you all, and I hope that we get to see each other very soon. Bye.